Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the Lorentz force and the velocity filter arrangement. So let us see a scenario in which there is a particle beam in which there are different particles which are moving with different speeds, and we wish to find out certain particles whose speed is v, and let us suppose that v is having some specific value, let's say 100 meters per second or anything else. So we need to filter out those specific particles which are moving with this speed v, irrespective of their charge and mass. So what we will do, we will use a velocity filter arrangement. But first of all, before moving to the velocity filter, let us discuss the Lorentz force. So let us discuss the Lorentz force, and we know that when a particle is moving in both electric and magnetic fields, then obviously the total force acting on the particle, which is the Lorentz force, will be the vector sum of the electric force acting on the particle as well as the magnetic force acting on the particle. So when a particle is moving in a combined electromagnetic field, then the vector sum of both the forces acting on the particle, which is electric force and magnetic force acting on the particle, is called as Lorentz force, and hence we can say that F Lorentz will be equal to QE plus QVB, and this is QV cross B. Obviously we know the vector form of this force, so this is the Lorentz force, and if we take Q common, then this is F Lorentz will be QE plus V cross B. This is the Lorentz force. Now if in the velocity filter arrangement we need to filter out those particles which are moving with some speed v, so we use a parallel plate capacitor. You can see a parallel plate capacitor. This is plate 1 and this is plate 2. The plate 1 is kept horizontally, obviously, and the plate 2 is also kept horizontally below the plate 1 at some distance, and these plates are parallel to each other. One of the plate is given some charge, positive charge, and the other plate is given some negative charge. Obviously they would be induced charges, and there would be a presence of electric field between these two plates from top plate to the bottom plate due to the presence of charge. Now we have also used two big magnets which are kept on the either sides of the gap of the plates, which means that we have created a magnetic field which is going inside this plane. So you can see that these magnetic lines are parallel to the plates, and these magnetic lines are perpendicular to the length of the plate. This is the length of the plate, and this magnetic field line is going inside the plane. So these lines are parallel to the plates, but these lines are perpendicular to the length of the plate. So these are going inside the plane of this screen, and the electric field is from top to bottom. So we can see that this is a cross field arrangement in which magnetic and electric fields are mutually perpendicular to each other, and in this case what we have done, we have used a certain combination of fields such that the net Lorentz force acting on those particles which we wish to filter out is 0. So this will be 0 obviously when QE will be equal to minus of Q V cross B. Now you can see that obviously if we talk about positively charged particles, then on those positively charged particles, let us draw this charge Q. you can see that electric field is in the downward direction, therefore electric force will be acting in the downward direction on those particles, and the magnetic force will be acting on the upward direction. As you can see that magnetic field is inside the plane and velocity is in this direction, therefore magnetic force will be acting in the upward direction. So these two forces will be opposite to each other, and you can see that the velocity of the particle is perpendicular to the magnetic field, therefore in this cross product there would be sine 90. So if we equate the magnitude of these two, then we can say that E will be equal to VB and V will be equal to E by B. Now we know that electric and magnetic fields are created by us only. So we can say that we have used this fields in such a way such that their ratio will be V. So for the particles which are moving with this speed V will have zero Lorentz force and they would pass through this velocity filter undeviated, and we can say that other particles would be deviated away from this stream, and we would get a filtered stream of the particles which are moving with this speed V. So this is the velocity filter arrangement, and this was used in early 80s, in fact in 19th century, to filter out many charged particles from the beam of particles which are moving with some different speeds. But we wish to find out the particles which are moving with some specific speeds, so we can pass that beam through the velocity filter arrangement, and there we can filter out those particles which we wish to filter out by using the arrangement of velocity filter. So in the next video I'll be bringing the cyclotron, which you have already heard about that, and the Hall effects in the upcoming videos. Thank you.